Hello everyone. For non-negative integers n, let f of n is equal to some expression is given, and we have four options to verify. Okay, so this question looks very big, but in fact it's a very easy question. I'll tell you I'll teach you different ways to solve this question. Okay, first of all, you observe that there is a pi divided by n plus 2 everywhere. So I'm going to replace. The first step you should do is you have to replace pi divided by n plus 2 as some theta. So whenever you do that, remember that pi is taken as n theta plus 2 theta. Okay, so n theta plus 2 theta will be equal to pi. So let it be there. Now our expression becomes f of n is equal to, we have an expression in the numerator which is sigma k is equal to 0 to n sine of k plus 1 theta into sine of k plus 2 theta whole divided by, so this division is this way, sigma k is equal to 0 to n sine square of k plus 1 theta. Okay, so the first method is you rewrite the numerator as 2 here, put 2 here. So the numerator is of the form 2 sine A sine B. 2 sine A sine B is nothing but cos of A minus B minus cos of A plus B. So let's rewrite there. And similarly in the denominator, 2 sine square alpha will be of the form 1 minus cos 2 alpha. So the numerator will be cos of, so there is sigma sign here, sigma k is equal to 0 to n, and there is cos of alpha minus beta is going to be theta minus cos of 2k plus 3 times theta, right, and divided by, we have sigma k is equal to 0 to n. This quantity is going to be 2 sine square theta is 1 minus cos 2 theta, 1 minus cos of 2k plus 2 times theta. So you distribute sigma. When you distribute sigma, this is n plus 1 cos theta in the numerator minus sigma k is equal to 0 to n cos of 2k plus 3 theta divided by, in the denominator we have n plus 1 minus sigma k is equal to 0 to n cos of 2k plus 2 theta. So we have an S1, one sum here, another sum here. Let's see what these two sums stand for. Okay, so S1 is nothing but, we have, when you put k is equal to 0, it is going to be cos 3 theta and cos 5 theta up to cos of 2n plus 3 theta. So this is basically in this form. This is in the form of cos A plus D plus up to cos of A plus n minus 1 into D. Okay, basically cosines of, sum of cosines of an AP, sum of cosines of an AP, sum of cosines of an AP. And you should know the standard result. This result is nothing but cos of A plus n minus 1 into d by 2 into sine n d by 2 divided by sine d by 2. Okay, in this case n is the number of terms, d is the common difference, a is the first term. So in this case we have our first term as 3 theta. So let's substitute that. First term is 3 theta. Number of terms is, in the sigma you can see the number of terms is n plus 1. So it will be n times. D by 2 is going to be theta, that is in the numerator, and denominator we have Oh, there is one more term in the numerator. That is going to be sine of n plus 1 theta divided by sine of theta. Okay, now this n theta, from here this n theta can be replaced as pi minus 2 theta. So let's replace that n theta as pi minus 2 theta. So this is cos of 3 theta plus pi minus 2 theta into sine of pi minus 2 theta plus theta divided by sine theta. So sine theta and psi pi minus theta get cancelled, and what is remaining is cos of pi plus theta. So that comes out as minus cos theta. So our S1 was minus cos theta. That quantity was minus cos theta. Now the second quantity S2 is again an expression in the similar form, but we have the first term as cos 2 theta plus cos 4 theta, and it goes on still cos of when you put n is equal to k is equal to n, it is cos of 2n plus 2 times theta. So again use the formula. It is going to be cos of a plus n minus 1. So in this case it will be n, d by 2 is going to be theta into sine of n d by 2. N d by 2 is going to be in this case n plus 1 theta divided by sine of theta by d by 2 is theta. Again cos of 2 theta plus n theta is pi minus 2 theta into sine of n theta is pi minus 2 theta plus theta divided by sine theta. So sine theta and sine pi minus theta gets cancelled, and the other term is cos of pi, which is minus 1. So our S2 is minus 1. Go and substitute this expression and this term. So this term will be n plus 1 times cos theta minus cos theta. S1 was minus cos theta by n plus 1 minus 1. So numerator we have n plus 2 cos theta. The denominator we have n plus 2. So the answer comes out as cos theta. And this cos theta is nothing but cos of pi divided by n plus 2. And that was our f of n. This is our f of n. F of n comes out as cos of pi by n plus 2. So the idea is you should remember this formula. You should know this result. You should know this result. Cos a plus d plus blah blah blah. That result you should be able to recall. But even if you don't know the result, you can do it in another way. I'll tell you what's the second method. It's using complex numbers. Using complex numbers, our S1 is cos 3 theta plus cos 5 theta up to cos of 2n plus 3 theta. So this is nothing but real part of e raised to I 3 theta plus real part of e raised to I 5 theta and so on, real part of e raised to I 2n plus 3 theta. So this is going to be a real part of e raised to I 3 theta plus e raised to I 5 theta plus up to e raised to I into 2n plus 3 theta. Now this is a GP with first term as e raised to I 3 theta and the remaining terms will be common ratio raised to number of terms minus 1 by common ratio minus 1. Now this can be rewritten as, see, from this e raised to I 3 theta, give one e raised to I 2 theta to this bracket. So it will be e raised to I theta into e raised to I 2 theta whole power n plus 2 minus e raised to I 2 theta divided by e raised to I2 theta minus 1. Now we know that n plus 2 times theta is going to be pi. So this expression is I2 pi. So that is e raised to I2 pi. E raised to I2 pi is 1. So we have 1 minus e raised to I2 theta by e raised to I2 theta minus 1. So we have real part of minus e raised to I theta, which is minus cos theta. So we got it without using the formula, but you should be very thorough with use of complex numbers. And similarly, the second sum, S2 was cos 2 theta plus cos 4 theta up to cos of 2n plus 2 theta. Okay, so this will be a real part of e raised to I 2 theta, the first term, into common ratio raised to number of terms minus 1 by common ratio minus 1. So you take e raised to I2 theta to this bracket. So this becomes real part of e raised to I2 theta raised to n plus 2 minus e raised to I2 theta divided by e raised to I2 theta minus 1. Again, we know this quantity theta times n plus 2 is pi. So this becomes e raised to I2 pi, which is 1. So this is again real part of minus 1, which is minus 1. So this way also you can do, and go back and substitute the value of S1 and S2. Another method is just observe that our f of n is this form. This is sigma k is equal to 0 to n sine of k plus 1 theta into sine of k plus 2 theta divided by sigma k is equal to 0 to n sine square of k plus 1 theta. So observe that this term can be written as k plus 1 times theta plus theta. Okay. So this quantity will be of the form sigma k is equal to 0 to n sine of k plus 1 theta times, I am going to expand this. This is of the form sine of a plus b. So it will be sine of k plus 1 theta cos theta plus cos of k plus 1 theta sine theta divided by sigma k is equal to 0 to n sine square of k plus 1 theta. Okay, so this quantity becomes sigma k is equal to 0 to n, and you can of course distribute sigma. When you distribute sigma, there will be two terms, and the first term you can take cos theta out. So this becomes sigma k is equal to 0 to n sine square of k plus 1 theta plus, in the second term you take sine theta out. The other expression becomes sigma k is equal to 0 to n. It is sine of k plus 1 theta into cos of k plus 1 theta. So it becomes sine of 2k plus 2 theta, and there is a half divided by sigma k is equal to 0 to n sine square of k plus 1 theta. Now these two quantities are same, so I am going to evaluate this expression for the time being. Okay, that expression is of the form k is equal to 0 to n sine of k plus 1 times 2 theta. Okay, and your 2 theta is nothing but 2 pi divided by n plus 2. Okay, so this is like, you know, we have a sine of, say if I am going to call this alpha, this is of the form sine alpha plus sine 2 alpha plus up to sine of n plus 1 times alpha. Okay, now you should know that this quantity is nothing but the imaginary part of all the n plus 2th roots of unity. So the n plus 2th roots of unity will be of the form e raised to I0, e raised to I alpha, e raised to I2 alpha and up to e raised to I n plus 1 times alpha. So you are talking about n plus 2th roots of unity. So this will be on the form imaginary part of e raised to I0 plus e raised to I alpha plus up to e raised to I into n plus 1 times alpha. Now this quantity we know the sum of n plus 2th roots of unity is 0. So this quantity is 0. Otherwise you could have used the GP concept again. Okay. Now this is coming as 0. So simply these two terms gets cancelled off and you are left with cos theta again. So there are multiple ways to approach it, but you should be very thorough with very comfortable with using the sigma notation. You should know some standard results. You should know how to write the complex numbers in polar form. You should have idea about cube roots or nth roots of unity and things like that. Okay. Now once you have f of n as cos theta, and cos theta is nothing but cos of pi divided by n plus 2, the options are just a cakewalk, because if you look at the options, once you have found that f of n is cos of pi by n plus 2, the options are very simple, because this becomes cos of pi by 6, which is root 3 by 2. That is right. That answer is right. And alpha is equal to tan of cos inverse of f of 6. F of 6 is going to be cos of pi by 8. So this is going to be tan pi by 8. Tan pi by 8 is nothing but root 2 minus 1. So if this is alpha, we know alpha plus 1 whole square is going to be 2. Alpha square plus 2 alpha minus 1 is equal to 0. That is also true. This statement is also true. Now the next statement is this. Again it is going to be pi by 7. 7 gets cancelled. Sine of pi 0. That is also true. Now limit n tend to infinity f of n. When n tend to infinity, pi by n plus 2 tends to 0. So this quantity is actually 1. So this is wrong. This is wrong. Okay. So very easy question. Once you find what f of n is. And if you can't do all this part, you can also try your luck. Okay. You observe that there is some role for pi by n plus 2, and you are going to call your pi by n plus 2 as theta. Okay. So we understand that it has some role in the question. Now what you do is you try to put n is equal to 0 and try to evaluate what f of n is. So when you put f of n is equal, put n is equal to 0, your f of n is going to be, so f of 0 is going to be, you just have one term on the numerator and there is one term on the denominator, and that will be sine pi by 2 divided by sine pi by 2 into sine of pi divided by sine square pi by 2, which is 0. Now you put n is equal to 1, your f of 1 will be, you have two terms in the numerator, which is sine pi by 3 into sine 2 pi by 3 plus sine 2 pi by 3 into sine 3 pi by 3 divided by sine square pi by 3 plus sine square 2 pi by 3. So the numerator will be root 3 by 2 into root 3 by 2 divided by root 3 by 2 the whole square plus root 3 by 2 the whole square, which will be 1 by 2. Okay. Again let's check for one more value. When you put n is equal to 2, your f of 2 is going to be sine pi by 4 into sine 2 pi by 4 plus sine 2 pi by 4 into sine 3 pi by 4 plus sine 3 pi by 4 into sine 4 pi by 4 divided by sine square pi by 4 plus sine square 2 pi by 4 plus sine square 3 pi by 4. So this quantity is going to be 1 by root 2 plus 1 by root 2 whole divided by sine square pi by 4 is 1 by 2 plus 1 plus 1 by 2. So this quantity is going to become root 2 divided by 2, that will be 1 by root. Now you observe that there is a pattern. Okay, so f of n value and n value. When n is 0, this value is 0, and when n is 1, this value is 1 by 2, and when n is 2, this value is 1 by root 2. You have not found out for n is equal to 3, but n is equal to 4, it is given in the question. You assume that that is also true. It is root 3 by 2. So you observe that there is a pattern, right? These numbers correspond to the basic trigonometric values. I mean the trigonometric functions of standard angles. Okay, so you also observe that pi by n plus 2 has some significance. So if you can quickly observe that your f of n is cos of pi by n plus 2, indeed this is satisfied, this is satisfied, this is satisfied, and this is also satisfied. Okay, so you should be able to quickly guess that f of n is cos of pi by n plus 2. In that case also you will be able to. So you should clearly, when you look at the options, you observe that your alpha is root 2 minus 1. So here also your f of 6 is coming out as cos of pi by 8. Similarly, if you assume that that is true, your f of 7 is coming as cos of pi by 7. No, f of 5 is coming out as cos of pi by 7, right? So if you can identify that pattern quickly, you don't have to do all this. You can easily get the answer right. So that's it. We have done it in multiple ways, but you should be able to know all these tricks and techniques.